Hey guys, Mr. Riz here to help you out with the next part of the 3.0. So another trick that we can use on the calculator, and this one's going to be super helpful, is graphing the derivative or finding the derivative. So we can't do this on Desmos. You can only do this on a TI-84. And so this is really where you want to make sure you have a graphing calculator that you can do that. So we have a couple of examples that just walk through how to do this, but let's take just a random example here. So I'll do something like, well, I'll do the first problem on your homework here. Let's look at this equation here where we have x to the third power minus 3x squared plus 2. And we can go through and graph. Oh, I got to change my window. If you ever get a weird looking window, if you just press zoom 6, that would go back to the standard graph. So pretty close to what we got here, just shifted over, but we have that cubic equation that goes up, down, and then back up. Well, there is another feature on our calculator that not only tells us the zero, but can actually tell us the slope at any single point. And that is, if we press second calc, we have our list of things that we can do here. We got mins and maxes, but if we look here, number 6, we have dy dx, and hopefully that sounds a little familiar. Dy dx is the derivative. So what this will do is actually tell you the derivative, and it's asking for you to point or click on a point here, and you can actually just type in, if we want to find the derivative at the point 3,2, we can just type in 3 for x and press enter, and it will tell us that the dy dx equals 9.00009. So what that's telling us here in our problem is that, and this is how we can do this whole assignment super easy, that the derivative at the point 3 is equal to 9. So before, back in the day, if we wanted to find the equation of the tangent line, that's what we have to do for all these problems here. We would have first had to take the derivative and say, okay, that this is 3x squared minus 6x. And then what we would have to do is to take 3 and plug that in. Okay, so what is 3 times 3 squared minus 6 times 3? All right, that's 27 minus 18. Okay, that is 9. All right, but now that we have the graphing calculator, we can actually do this real quickly. So the last thing we got to do here is actually use y equals mx plus b. We do have our x and our y from our point, and now our derivative that we got from our calculator super quick tells us the m. So we're going to plug those pieces of information in. So we get, let's see, this would be y is 2 equals m is 9, x is 3 plus b. And so we get 2 equals 27 plus b, and we get 25 or negative 25 equals b. So the equation for the tangent line would be y equals 9 is our slope, x minus 25. And since we have a graphing calculator out, if we just make a whole nother equation here separately and say, okay, y equals 9x minus 25, we should see at the point 3,2, which is about right here, 3,2, that the tangent line crosses or touches the original graph and only that point right there. It's pretty cool. All right, so we'll do another problem here just to kind of get you guys familiar with those steps that we just went through all over again. All right, so what if we have, well, we already did x cubed. Let's do this one here, this weird looking graph. So if you think about it, every single one of these problems here, we want to do y equals mx plus b. We have our x and our y from our point, and we can get the slope if we want to just use the calculator. So if we didn't before, we'd have to do like the quotient, right? Low d high, high d low over low low. Do all that crazy work, get that answer, plug in 1 to get the slope. Now we can kind of cheat, use the graphing calculator out. So we got negative 3 divided by, now since we have an expression down here, we need to put in parentheses, x squared minus 4. We can graph it out. So there's our equation. So let's find the derivative at the point 1. And to do that again, we press second calc, and we're going to pick our sixth choice, dy dx. And we're going to type in 1 because our x value is 1. So what that will do is actually, it does like, it picks 1 and then 0.111. It goes through. So it doesn't give us the exact slope, but it gives us something super close. And so we get 0.6666674, which you guys can probably think that's supposed to be 0.666666. So we can say that the slope is 2/3, 0.666. Hopefully you guys know it's 2/3. So we can get our answer here by using our y is 1, our m is 2/3, our x is 1 plus b. we want to solve for b, all we need to do is subtract 2/3 from 1. That leaves us with 1/3. And so we can type in our answer, y equals 2/3 is our slope, x plus 1/3. And might as well, since we have the graphing calculator out, let's verify that. So have our derivative, our equation here. We get y equals 2/3 x plus 1/3. Graph that out. There we go. Yep, there's the 0.11, and it looks like our tangent line just touches that point. Now, I know it touches here later on, but we're just talking about specifically in this small region. All right, so let's also talk about why this equation and this technique is really useful. Because now we can do derivatives of things that we haven't really gone over. I think we might have once or twice talked about what the derivative of the natural log is, but if we don't know it, we can use the calculator here to help us out. So we're going to go ahead and graph the equation here, and we're going to find the slope at -2. So we still are doing y equals mx plus b. This is our x, this is our y, and we can use the derivative to find the slope. And so to do the derivative on the graphing calculator, we press second, calc 6, and we're going to type in -2 as our x. And then it tells us it's -0.5, which we all know -0.5 is -1/2 as a fraction. So we're going to plug in our y, which is natural log of 2, equals our m is -1/2, our x is -2 plus b. So we get the natural log of 2 equals 1 plus b. All we need to do is to subtract that 1 over from natural log of 2, and so that just becomes natural log of 2 minus 1. So kind of a weird equation that we're going to get here, but we'll get y equals -1/2 x plus natural log of 2 minus 1. So not the prettiest looking answer, but that was pretty easy to get. So we actually don't need to use the graphing calculator. We could have done this the long way by taking the derivative of all of these equations here and go through and, do y equals mx plus b. But if we have the graphing calculator to help us out as a tool, this makes it a whole lot easier. So the rest of these problems here, you guys will do y equals mx plus b. It's not too bad, but I want to show you guys one more trick on the graphing calculator. So let me go through and let's start off with this original equation again. And let's go through and type it in. So we got x to the third minus 3x squared plus 2. So we have this graph here. What we can actually do, we can actually have the graphing calculator graph the derivative as well. Not just figure out what the derivative at a single point is, but we can have it graph the entire derivative. And this is how we do it. Notes are above. But what we're going to do is here, instead of typing in a new line or actually trying to figure out the derivative, it's too hard. We know that's 6x squared plus 3, or oh my God, 3x squared minus 6x. But what we can do here is if we go down, if we press, is it math? Yep, and we're going to go down a little bit. We press math, and we're going to go down to here to number 8, where we have and deriv. If we think about it, that means we're going to take the derivative. So we get a little fancy thing here, and we got to just type a couple things in the calculator. First, we're going to put ddx, and we'll type in our equation. So you guys can retype in this equation, or if you want to cheat, you can press vars, go over to y vars, press 1 for function, and press 1. So what this does here is substitutes whatever you typed in here to right there. And then we got to say x equals x. And that's some calculus 2 stuff, but just remember this is always ddx. You type in your y1 equation, or you press vars and kind of cheat that way, and press graph. And what it does is actually figures out the derivative, or finds the slope of every single point and plots those. And if we really kind of want to double check if we did the graph or derivative correctly, if I type in 3x squared minus 6x, all right, think about original is in black, our derivative's in red, or original is blue, our derivative is in red, and what we think the derivative is, the equation for it is in black. If we graph, you can see the black just completely covered the red. So we know we did this exactly right. So we can kind of use this calculator to not only just verify our derivatives, but find some things out too. And so this is going to be extremely helpful later on when we do some more complicated things with some derivatives, because we can use the graphing calculator to kind of cheat. It's a tool that we can use to help ourselves. All right, guys, so finish this page up here. If you have any questions, ask. If you don't have a graphing calculator, see if you guys can borrow one for like at least the next couple months until school's over. You guys have a great day. I will see you later.